One of the key concepts in AP Physics is the difference between scalars and vectors. Let's imagine somebody running around a racetrack. When I was in my senior year of high school, I was on the track team. I ran 400, 800, and 1600 meters. They were killer distances. So let's imagine there's somebody running around the racetrack and they do one loop. The track is 400 meters. The person goes all the way around the track and they're very happy they ran 400 meters. And they say, I ran 400 meters. My distance was 400 meters. And this person has a friend who is watching and is a bit sarcastic. And the friend says, you're in the same place that you were as before. You haven't gone anywhere. Your distance is 0. And the friends can have an argument. They can say, I went 400 meters. And the second sarcastic friend can say, you didn't go anywhere. You went 0 meters. So what's the truth? And we have a distinction in physics here between distance and displacement. So this one, the person who ran, is actually talking about distance. And the second person is talking about displacement. Displacement only cares about the initial position and the final position. So here's a house and somebody walks through a tree, but they take a lopsided path. Some wandering path like that. The distance is the distance of the whole path, wandering like that. But the displacement only cares about the difference between the 2 points. The straightest line between 2 points. There's even an equation for displacement. The displacement is df minus di. So this is the final location, and this is the initial location. So the displacement is the difference between those two. We could call it delta d, or even delta x. We might call it delta d to indicate a difference or displacement. We might call it delta x to indicate it's a difference in x positions. The best way to improve your grade is with a practice test. On my site, I have a free Kinematics practice test. Click the link below to get your free test today. So this illustration is hinting at the idea of scalars and vectors. So trying to divide the board down in two. So there's two kinds of variables in physics. Variables are either scalars or they're vectors. A scalar is something with a magnitude, and a vector is something with a magnitude and a direction. In our illustration about displacement and distance, distance is a scalar, and displacement is a vector. So in my woggly house example, I might say the displacement between the house and the tree is 5 meters in the west direction. So I always, with a proper vector, have the magnitude 5 meters, that's how big it is, and a direction. So in this case, the tree is to the west of the house. If I were to go from the tree to the house, that would be 5 meters east. This is actually a different vector. 5 meters to the west is one vector, and 5 meters east is a different vector because they have a different direction. They're actually different vectors. With a distance, I don't have the direction as part of what it is. If I take this woggly path, I might have a total distance of 10 meters that I walked. But this 10 meters, I don't put a direction on it because it's not in any particular direction. It's going all around. So the distance here is 10 meters. The next example of scalars and vectors is the difference between speed and velocity. In physics, we say speed is a scalar and velocity is a vector. So these are very similar things, and they're both talking about the same idea. But the difference is, with velocity, we care very much about direction. And with speed, we don't care about direction so much. In your car, there's a speedometer, and we might say, I'm traveling down the road at 40 miles an hour. So here, 40 miles per hour, that's a magnitude, a number of how big the speed is. And there's no direction on it. So it's not a true velocity. It's a scalar. It's just a number with a size. And we're very used to talking about this. I know what it feels like to drive 40 miles an hour in my car down the road. If I want to make it a vector, I have to add a direction. If I were to say that the car is moving 40 miles an hour to the west, now it's a vector. It's a vector because there's a direction and a magnitude. Magnitude is 40 miles an hour. The direction is west. I can call the directions right or downwards or towards that tree. Any kind of direction is fine, so long as I clarify for the sake of physics that there is a direction on this. There's a third example that we need to think about for vectors, and that's acceleration. So with acceleration, I might say a car is accelerating at 2 meters per second to the west. Acceleration is a vector because we say the magnitude and the direction of that acceleration. Now, it's not a wrong thing to do to say sometimes a car is accelerating at 2 meters per second or something like that. But when we're in physics and considering acceleration, we always want to consider it as a vector and think about including a direction as part of our answer for what an acceleration is. So in physics, there's a lot more variables that we're going to learn about that fit into these different categories of vectors and scalars. We'll learn about forces that are vectors, and we'll learn about energy, which is scalar. However, for kinematics, these are the ones that we care about. And we're really actually going to be thinking about these three. We care more about vectors in physics because we can do some more fancy math things with them. And displacement, velocity, and acceleration. These three are the key focus for the chapter of kinematics. This idea of scalars and vectors may be completely new to you. What questions do you have about this idea of vectors and scalars? Write your questions in the comments below. I read all the comments.